So, quiz 3, chapter 2, sections 2.1 to 2.4. Let's look at that. So this first problem, we're going to simplify. So we get 7 plus 7i. Drop the parentheses here. This is minus 8 plus 7i. And so we get the like terms together. So that's the 7 minus the 8, and then plus 7i plus 7i. So 7 minus 8 is -1, and then plus 14i, and that's written in the standard form. Multiply, so we do the FOIL, first time the first. 64, outer times the outer is minus 32i, inner times the inner plus 32i, last time the last is minus 16i squared. Now those inside terms cancel out because they're opposite. And so we have 64. This is minus 16 times -1. You recall the I squared is equal to -1. So this is just 64 plus 16. So here we get 80. Still multiplication. We're going to have to write this out. 7 plus 9i times, again, 7 plus 9i. And then you FOIL that. So the first time the first, we get 49. Then the outer times the outer. So that's plus 63i. Inner times the inner is another plus 63i. And then the last time the last is plus 81i squared. Right? And so we bring down the 49. We add these two terms here in the middle. They're like terms. And then this is just minus 81. You remember the I squared, again, is -1. And so we simplify that. So won't that be just a negative 32 plus 126i? And again, that's written in the standard form. So you don't forget when you do the multiplication on that FOIL, you got two of those terms in the middle. You know, some people mistakenly would read this as being the 7 squared, 49, and then they would have plus 81i squared. This is incorrect. That's not what that says. It's just not squaring the 7 and squaring the 9i. No, no, no. You know, Santa Claus, ho, 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 but mathematically, no, no, no. Anyway, I just made that up. So you want to make sure we do everything the right way. Here, you recall to divide and express the result in standard form, we need to get rid of the I downstairs. To do that, we multiply to the top and the bottom by the conjugate of the denominator. So this, you distribute the 4 through the numerator. So this is 12 plus 4i, and then on the bottom, it gives you 9 plus 1, or just say 10. when you FOIL the differences of two squares, that the inner parts cancel out, right? I mean, if you work it out, everything is fine. First and the first is 9. Outer times the outer is plus 3i. Inner times the inner is a minus 3i. They're going to cancel. I mean, that's the whole reason why we're multiplying by the conjugate. And then the last on the last is, that's a minus I squared. Sounds like something we ate last night. Minus I squared. But anyway, let me write this. This is 12 plus 4i. We simplify that. That's 12 plus 4i over, this is 9. Now those inner terms cancel. And then this is that minus I squared is minus times the negative 1. Remember the I squared is negative 1. So that's just positive 1. So we just get 1. So this is 12 plus 4i all over 10. Simplify that. That's 12 over 10 plus 4 over 10 times I. Let's take it one more step. Reduce. We're going to reduce that to lowest terms. So the 12 tenths is the same thing as 6/5 plus the 4/10 is the same thing as 2/5 times I. Now that's written in the standard form. More of the same. We multiply the top and the bottom by the conjugate of the denominator. So that'd be 5 minus I up top, 5 minus I downstairs. So we multiply through, so we have 104I times 5. That's 520I. And then is minus I times 104I. So that's just minus 104I squared. Now, go ahead and work that bottom out because we know what's happening. That's just the first squared, 25. Then it's plus the last squared, which is just going to be 1. So now that I squared here just becomes negative 1. So it's going to be negative times a negative. So we get 104 positive, right? Plus 510I all over 26. And on your calculator, you can simplify that. So this is 104 over 26 plus 520 over 26i. The I is in the numerator. So that is just 4 plus 20 times I. Let's make sure, check that again. 520 divided by that 26 is indeed 20. All right, let's simplify this one first. So this is the minus 3's in parentheses minus, you can take that negative out the radical and make it an I on the outside times the square root of 7, all to be squared. Remember, this is broken up into 2 pieces, just repeating itself, right? So now we FOIL that. So the first time the first gives us 9. The outer times the outer is, well, that's plus 3i times square root of 7. Inner times the inner, multiplying 2 negatives, we get plus there. 3i times square root of 7. The last time the last is negative times negative is positive. That's I squared times 7. So this is 9 plus 6i times square root of 7, and that becomes minus 7 because the I squared, you remember, is negative 1. So this is 9 minus 7, like terms you combine, so we get 2 plus 6i times the square root of 7. And that's written in the standard form. You can kind of make it 2 plus, this is 6 times the square root of 7. I'm cautious about putting that I there. You make sure you don't write that I inside that radical, but that's just to show that it's in standard form, right? Okay, more of the same. We're going to simplify this. This is minus 8 plus, we can take out an I, but let's just work out and see what's in there. This is a negative 1, and then it's a 4, and then a 3, all over 40. So that's a negative 8 plus, that's the square root of negative 1 is an I on the outside. The square root of 4 is just 2 times the square root of 3. Can't break the square root of 3 down, all over 40. So we get negative 8 over 40 plus 2i times the square root of 3 all over 40. I guess you put that I on the back. That's fine. So we can reduce this. This is negative 1 over 5 plus the square root of 3 all over 20 times I. Use the quadratic formula. It has to be in the form of the quadratic equation. So if ax squared plus bx plus c is equal to 0, this implies that x can be written as negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So using that formula, notice here that a is equal to 1, b is equal to negative 10, and c is equal to 50. So using that, we get x is equal to, here, a negative times that negative 10, plus or minus the square root of the negative 10 to be squared, minus 4 times a, that's 1, times c, that's 50, all over 2 times 1. So we simplify that. This is 10 plus or minus the square root of, that's 100, minus 200, all over 2. And so this is x is equal to 10 plus or minus, that's the square root of a negative 100, right? All over 2. So this is x is equal to 10 plus or minus, the square root of 100 is 10, the square root of negative 1 is I. So this is just 10i all over 2. So we can write our answer as the 10 divided by 2 is 5 plus or minus 10i divided by 2 is 5 times I. Okay? So let's keep on pushing. All right, we have to write that in the form. Remember, it says if ax squared plus bx plus c is equal to 0. This is not written in that form. So we say this implies then that we have 4x squared minus 2x plus 3 is equal to 0. Now it's in that form. Then we have x is equal to negative b plus or minus, is that a plus or a bird flying? Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we put the terms, so a is 4, b is negative 2, don't forget your sign, c is 3. So x is equal to negative times b, negative times the negative 2, plus or minus the square root of the negative b, well, I'm sorry, just b squared, but b is negative 2, I got a couple things in my head going on at one time. No, I'm not smart. I'm just confused. Anyway, 4 times A. The A is the 4, and the C is the 3, all over 2 times 4. Then we just simplify. This is 2 plus or minus the square root. That's 4 minus. That's 16 times, is that the 3? Yes. 16 times the 3. So we get 48. So minus 48 all over 8. And so here x is equal to 2 plus or minus. This is the square root of negative 44 all over 8. So x is equal to 2 plus or minus. Now that negative 44 is negative 1 times 4 times 11. So we know the square root of negative 1 is going to be I. The square root of 4 is 2. So we have 2i, and then we leave the 11 in that radical all over 8. And then finally we simplify, divide each term there by the 8. So we get 1, 4 plus or minus here I over 4 times the square root of 11. Okay. All right. So let's see what this is all about. So find the coordinate of the vertex. Well, it's already in the form. Remember, we said that if we have f of x is equal to a times the expression x minus h to be squared plus k, then the vertex is h comma k. Right? So our vertex here would be 6 comma 1. Here, find the vertex. It's not written in that form, so we complete the square. Complete the square to get the vertex. Okay. So we factor out a 3 from the first 2 terms. So this is 3 times parentheses x squared plus 6x plus 1. Then we said after that, you take the coefficient of x, which is 6, take half of it. So we take the coefficient of x is 6, take half of it, we get 3, and then we're going to square that 3. And we get 9. So we take the 9 and we add it and subtract it within the parentheses. So here we get 3 times parentheses x squared plus 6x plus 9 minus 9. Just to show you that we just added a sophisticated 0. We have not, didn't change the problem. That is, we didn't mess it up, right? So now we're going to take the negative part out. So this, we have 3 times parentheses x squared plus 6x plus the 9. Leave that plus 9 there. Take the negative out. Take it by the front door. So we bring it out, multiply it by that 3. So we have negative 27 on the outside plus 1. And when we can factor here the parentheses, it's a perfect square trinomial. It is always the x plus that number there that you worked on, right? So it's x plus 3 all to be squared. This is minus 26. So the vertex is negative 3 comma negative 26. you remember that the equation has to be of the form x minus h to be squared plus k. Right? So this is x minus a negative 3. Right? So what we have is 3 times parentheses x minus a negative 3 all to be squared plus that negative 26. Right? And all they wanted there was the vertex. So here, use the vertex and the x, the intercepts could be x and y. To sketch the graph, find the axis of symmetry and the domain and range. So notice this is in the standard form. We can write it like this. So the vertex is that 3, 1. The domain and the range, well, I like to get those by just looking at the graph. So that's interesting how they pose that. So let's go over here and see if we can plot this graph. We know it's a parabola. It's going to be curving down because of that negative sign, right? So the parabola is going to do this. The vertex we got at 3, 1, and then it's going down. So I need to find maybe another point or two so I could try to be as accurate as possible. So here, let's just pick x to equal to 4. So I have f of 4. I'm just trying to find another point on the graph. So this is 1 minus 4 minus 3 to be squared. So f of 4 is equal to 1 minus 1. That's 0. So 4, 0. I'm there. All right. That same thing happens at 2, 0. I don't really need it, but I mean, it's good to have. So this is 1 minus 2 minus 3 to be squared. This gives me 1 minus 1 again, and that's 0. At 2 minus 3 is negative 1 to be squared. That's just 1s. We get 1 minus 1. So here I get 2, 0. You get that. So I just needed that to know really the range. The range is going from negative infinity all the way up, and that looks like that's 1. So the range goes from negative infinity to 1. The domain for the x values, as the parabola goes down to the left and to the right, it's going to tether to the left and to the right, downward. So it's going to pick up all these values. Okay. So for this one, find now that previous problem, well, that's all it had there. So maybe I didn't. Oh, the axis of symmetry. I'm sorry, I can't read. The axis of symmetry is going to be this equation that we get from that. So it's just x equal to 3. Yeah, I kind of felt I was missing something. They didn't ask for the vertex. It says use the vertex and intercepts. Okay, gotcha. No problem. So here, use the vertex. Well, what is the vertex? So let's complete the square. So this is x squared plus 12x. Look at the coefficient of x, which is this 12. Take half of it, I get 6. Square it, I get 36. Add it and subtract it. Then it was that plus 6 that was already there. So here, I mean, the cool thing for us, we don't have any parentheses. So for these guys, just factor. That's x plus 6 all to be squared. On the outside, we have minus 30. So the vertex would be negative 6 comma negative 30. They want the x-intercepts, so we set the function equal to 0. Solve for x. So I'm just going to take what I have. So I have x plus 6 to be squared minus 30 equal to 0. So I get x plus 6 to be squared is equal to 30. Take the square root of both sides. X plus 6 is equal to plus or minus equal to plus or minus the square root of 30. So x is equal to negative 6 plus or minus the square root of 30. So it says for the x-intercepts, it's an ordered pair, use a comma to separate the answers. And it says type the exact answers. Exact answers always include the radical. The radicals of reconstruction. So there, for that answer, we have negative 6 plus the square root of 30, comma, negative 6 minus the square root of 30. Okay. So it said separate your answers with that comma. For the y-intercept, we said x equals 0. Let x equals 0. So this implies that f of 0 is equal to 6. Go back up, put a 0 in, for that x, right? Just get 6. So here, this is 0, 6. And it looks, type in ordered pair, so I better go up here and do that correctly. I don't want to mess you up. Ordered pair would be for the x-intercept, negative 6 plus the square root of 30, comma, 0. Close that up, comma, and then parentheses, negative 6 minus the square root of 30, comma, 0. Yeah. I tell you, I'm having a rough day. And now, so use all that information, let's graph this sucker. So let's see, the vertex is, now notice that it's a parabola. It's going to be shifting up on both sides. It's going up because a is equal to 1. A is positive. That's the main thing. So if that's the case, then we can rule out C. So now let's find the vertex, negative 6, negative 30. That's going to be in the third quadrant. So if that's the case, then we can rule out D, because that's over in the first and fourth quadrant. So it looks like here that negative 6, negative 30 looks to be there. And then we have that y-intercept of 0, 6. That's about there. That looks good. See how this guy drops down a little bit lower than negative 30 for B. And then the y-intercept is under the x-axis. Oh, no. Right? Kind of tricky. All right, that same problem, the axis of symmetry. For the axis of the symmetry, I look here. And so that's just x equal to negative 6. You see that? The domain, go back to that graph to get the domain and the range. So the domain is from negative infinity to positive infinity for the domain. Okay. The range we go back again, look at the graph. That bottom number for the y value is negative 30. And then it goes up to positive infinity. That's for the domain. Then for that range, goes up there, but its lowest value is here, right? And that was y equal to negative 30. So we got that from the vertex, right? So this is going from the lowest value, negative 30, all the way up to positive infinity. Always for the domain and range, we always go from least to the greatest, from left to right. Do we get everything there? I believe so. Just looking at this this guy, they want you to find the determine whether or not it has a minimum or maximum. What does it? Does it have an extrema? That's what that means. Extrema means a minimum or maximum. It does because it's a quadratic function, and so it has the parabola shape. So it's either going to be shifting up or shifting down. Well, it's going to be shifting down because of that negative 3. So a is equal to negative 3, right? It's less than 0. So that means that if the graph is falling, then it has to have a maximum somewhere. Maximum. So here we get a max. Now they want us to find the stupid thing, right? And you know, we had these problems all the way through you know, math classes where, you know, if you're gonna ask just whether or not something exists, just keep it like that. Don't ask me to find it if it does exist. Well, we can get that a couple of ways. You can use that formula, or what formula am I talking about? You can use x equal to negative b over 2a, and then f of negative b over 2a. I'm just going to complete the square if I can. If I can complete the square, that's my go-to. So we go back to the problem, factor out that negative 3 from the first two terms. This is x squared minus 2x. Then on the outside, we got that minus 2. It's negative 3, x squared minus 2x. Take half of the coefficient of x, that's the negative 2. Take half of that, we get negative 1. Square it, we get 1. So we're going to add 1 and subtract 1 within the parentheses, minus 2. So it's 3 times. I'm going to go ahead and factor these guys, take out the negative 1. So when I factor what I have there in that's highlighted, that's just x minus 1, all to be squared. Take out that minus 1, go by the front door, that's negative 1 times negative 3. That's a positive 3 on the outside, minus that 2 out there. We come over here, that's really f of x. This is equal to 3 times x minus 1 to be squared plus 1. So that means that the vertex, VER, is 1, 1. So what does that mean? That means that the x value is 1, and then the function value, that max, that's what they're talking about. So we put that value. Luckily for us, we get the same numbers, but you understand that the x values here for where this maximum occurs, that's 1, that's the first value, and then the y value goes here. Well, just for us, it happens to be the same. 1, 1, that is. What's the domain and the range? I don't know about you, but I have to graph it so I can see it. So I find the vertex 1, 1. A is negative, so it's going down. I'm going down. Boom, boom. Now, what's that highest value there? That's 1, right? That's the y value. So the domain, all these guys, if you notice, if it's a quadratic you know, with respect to y basically equal to x squared, the domain is always the same. The range would go from negative infinity up to that 1. See if I can put it here so you can see it. Okay. And you know, most all these problems we did in class. So this one used the leading coefficient test to determine the end behaviors. I went ahead and just put the dang on graphs, you know, in there. But on the test, you have to match them up. So that's that. You remember that leading coefficient test? We have, you know, f of x defined as a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus and so on, plus a sub 1 times x plus a naught. So we consider the n is our degree and a sub n the leading coefficient. So we look at the leading coefficient, we look at the degree, right? And so if the leading coefficient is negative, if the degree is even, then the graph falls to the left and to the right. If the degree is odd, the leading coefficient is positive, here's 1, then the graph falls to the left, it rises to the right. If the degree is even, and if the leading coefficient is positive, then the graph it rises to the left and to the right. And then over here, if the leading coefficient is negative and the degree is odd, then the graph does the opposite of what happened over here for 16. The graph will rise to the left and fall to the right. Okay. Find the zeros. If it's factored, you're done. X equal to 5, x equal to 8, right? It's a cool thing about that. If it's not factored, you have to factor it and then get the zeros. Notice that x equal to 5, since it has multiplicity of 1 is odd, it's going to cross there, but then at x equal to 8, it's going to touch because the power there is even, the multiplicity is even. So we have 2 zeros, and so we don't have 3, so no, we don't have 1, so we have 2. The multiplicity of the smallest 0 was 5, right? So that guy has the power of 1. The multiplicity of the largest 0, which is 8, we got a power of 2. And then here, determine the behavior of the function. Select the best one. So the graph touches the x-axis and turns around at all values. Nope. It's going to cross at 5. It's going to touch at 8. So the graph crosses the x-axis at x equal to 5, and then it turns around. Turn around. Okay. Anyway. All right, more of the same. Here's already factored, so I have 9 and negative 8. Make sure you get your signs right. Okay. So here we have 2 zeros. So the multiplicity, so it's going to be this one, the multiplicity of the largest 0. Well, the largest 0 is 9. Just look at the numbers, which is smaller, which is larger. So its multiplicity is 1. That's to the first power. That's all they're talking about. The multiplicity of the smallest at negative 8 is 3. Its power is 3. Okay. Well, since the multiplicities are both odd, so here the graph it crosses at these values. So the graph crosses the x-axis at all zeros. It's going to be that one. Okay. So here, and we want to use the intermediate value theorem, which simply says that if you can test the function at two values, and if the sign changes, then that has to imply that the graph crosses the x-axis. Very phenomenal. You know, I'm telling you. I mean, whoever came up with that, hey, give them a Scooby snack, right? So let's see. So we find f of 1. That's going to be 2 minus 3 minus 5. Right? So that's negative 1 minus 6. Good. And then we find f of 7. So that's 2 times 7 to the third minus 3 times 7 minus 5. And that is 660. So the signs change. This guy is negative, and this guy is positive. So at f of 1 is under 0, we get negative 6. And at f of 7, we get 660. It's greater than 0. Yep. All right, parts A to E. I'm going to graph this sucker. So use the leading coefficient test to see what's happening. Well, the leading coefficient test, we get from this that n is 3 and a sub n is 1. So we get odd and positive, so it falls to the left and it rises to the right. So falls to the left, the graph falls to the left and rises to the right. It's this one. Now to get the x-intercepts, dang gun it, we got to factor. Is there room in the end? All right, so let's factor this. Looks like x squared is common in the first two guys. And then to match it up, looks like a negative 1 is common over there. We get x minus 4. See that match up? Match it up. Match it up. Now don't force it now. Don't make up math. Some folks be just making up stuff, putting numbers there. Old teacher in grade school would say, give me your hand. Boy, they give you a whack. Okay, so now we're going to factor that x minus 4. And notice what we have left. You have left x squared minus 1 in parentheses. Write it down. Dr. Sampson at the convention would say, wake up and write it down. Now we can factor that a little bit more. So we have f of x is equal to, this is x minus 4. You can factor that x squared minus 1, that's x squared minus 1, that's x minus 1 times x plus 1. So now do you see that our zeros would be x equal to 4, x equal to 1, x equal to negative 1. If you're from the country, you say it's 4. Anyway, so and it doesn't matter about the order. So 4, comma 1, comma negative 1. All right. Now notice that all these powers have power of 1. So that means that at each of these x-intercepts, the graph crosses the x-axis. So let's see here. So at which x-intercepts does the graph cross the x-axis? Select the choice below. Well, it's going to do it for all of them. So you're going to say 4, comma 1, comma negative 1. It's going to be this answer. What's the y-intercept? The y-intercept, let x equal to 0. Let x equal to 0 and solve for y. So we're looking for f of 0. Just plug in where you have x, put a 0 there, you end up with a 4, right? So y is equal to 4. Is there symmetry? I don't know. I have to graph this thing. Now my way of graphing is to do a number line, break up the number line based on the x-intercepts. So counting from left to right, I get to a -1 first, and then a 1, and then that 4. Now I know what the end behavior is going to tell us. The end behaviors tell us, I erased it, but it falls to the left. That means it's negative over here. Let's put that in red. It means that red, I said, hey, red. And then it rises to the right, right? So that means rise means plus. So all we got to do is just to check what happens here and there. Just want the sign. Show you how powerful this is. This is my method. Well, anyway, just take a number on this interval. Easy number. I took 0. Then take, let's say 2. Just want the sign, right? So f of 0, we got that to be 4. It's positive. Put a plus sign there. F of 2, again, I'm just looking for the sign. You plug in x equal to 2, and that gives us, I knew there was I was doing it in an easy way years ago. Let's put it here, f of 2. So this is 2 to the third minus 4 times 2 to the second minus 2 plus 4. So f of 2, this is 8 minus 16. Minus 2 plus 4 is just plus 2, right? And then this is minus 8 plus 2. I get minus 6. I just need the sign. It's negative. Put a negative sign. I got it. I'm ready to go. Now, again, we're just sketching. It's not accurate because I cannot determine with algebra the max or the minimum of these polynomial functions. If it's a quadratic, I can, because we can find the vertex for that. But this is x to the third. So we need calculus to actually get, close to the exact graphs. But we can sketch the heck out of it and be very close and be satisfied, right? And go home and get some dinner and watch Lester Holt and then watch some basketball and then go to bed. So, well, kiss your wife, right? Kiss your wife, kick the. Okay, anyway, so -1, x equal to 1, x equal to 4. And then we had a y-intercept at 4. So from -∞ to -1 is going to be under the x-axis. That's where we got that negative right here. So that means it's down. It's down, and it goes from -1 to 1, it goes plus, it goes up. From 1 to 4, it goes down, and then from 4 to positive infinity, it goes up. So we're just gonna do that. So here it's below, goes up, drops down, does that. And as the kids used to say when I was a kid, pew! I'm trying to make it smooth. Try to break it up like that is crazy. As smooth. It's not a spike there. It's just how I'm drawing. Now that guy, it probably does. It could be doing something like that, right? But again, this is just sketching, right? Yeah. Now the good thing in my math lab, when you select that shape over there in that corner, you select the shape, and you put those points that it's going to put in there what it ought to be. It's going to help you out. It's just like playing a video game if you can play it right. Well, oh yeah. Then it says, is there symmetry? Heck, that graph looks like crap. There's no symmetry there. Anyway, I shouldn't say crap. Long division. So let's divide x plus 1, divide it into here. Make sure everything is listed in descending order. Insert zeros if necessary. So x goes into x cubed, x squared times x is x cubed, x squared times the 1 is plus x squared. Draw a line, subtract. So here, these terms cancel. That's fine. 3x squared minus x squared is 2x squared. Right? Bring down the plus 5x. So first we divided x to the third by x. It gave us that x squared. Put that up there. And then secondly, we're going to divide 2x squared by x. So we get plus 2x. So we'll put a plus 2x there. Multiply 2x times this binomial. So we get 2x squared plus 2x. Draw a line, subtract. Becomes negative. This becomes negative. They cancel out. We have here 3x. Bring down the next term. Plus 3. So now let's divide the 3x by x. Gives us plus 3. Should say that. So we add a 3 there. Multiply 3 times the binomial. So we get 3x plus 3. Draw a line, subtract. We get remainder 0. So remainder 0, and then the term that goes there is what we have here. And so that's x squared plus 2x plus 3. All right. So synthetic division, so we're going to use here x, we need x equal to -4. Put the -4 there. List the coefficients of the polynomial. The coefficients, 2, 7, -3. Always bring down the first term. Multiply -4 times 2, we get -8. Add, we get -1. Multiply -4 times -1, get 4. Add -3 plus 4, we get 1. The degree initially was 2, so this degree bumps down n minus 1. Right? So that means here that this is 2 times x to the first power. That's what I'm saying there. Minus 1, and then plus the remainder is 1 over x plus 4. All right, 2 more problems. Now this problem is important because this problem matches your student learning outcome. Yes. All right. So let's see what's happening here. A ball is thrown upward and outward from, now which is it? Is he throwing it up or is he throwing it out? Anyway, from a height of 6 feet. The height of the ball, f of x, in feet can be modeled by that quadratic equation, where x is the ball's horizontal distance in feet from where it was thrown. Excuse me. Talk about horizontal distance. Here they're talking about this. That's x, so that's what he means there. what is the maximum height of the ball and how far from where it was thrown does this occur? This is just the vertex from the quadratic um, equation. Right? So the maximum height would be the k, and then it occurs at x, that's going to be the h. So we can do that by using the formula. We got those decimals, so I do not complete the square. Try to make it easy on myself. Try to make it light on yourself. So this is negative. The b is 2.1 divided by 2 times negative 0.4, right? And that comes out to be 2.625. And it says to put your answer in the nearest tenth. So now that's the x value. So that guy goes here. That's the 2.6. Then it says find the height. That's just the function evaluated at this point. So negative 0.4 times 2.625, that to be squared, plus 2.1 times 2.625 plus 6. So we get this height. That guy comes out to be 8.7, 8.756. And we'd just say 8.8. So we'll round up. Right? So the height would be the 8.8. It says, how far does the dang on ball travel horizontally? Now, you just found the height where it was here, right? So at that value, that was the 2.6. Now they want you to find this value. So to find that, we use, notice here that y is equal to 0 at that point. Y is equal to 0. So find x when f of x is equal to 0. But what is that? That's the quadratic formula. That is, use this. You remember it said that. It says if ax squared plus bx plus c is equal to 0. What 0 is that? That's that 0 there. Same thing. Then x can be found by that formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Took my sins and put them in a bag. Let's put that in a bag, box, square. And then he threw, the bag away. Anyway, let's see. So we got to use that formula. So let's see what we have. We have a is negative 0.4. B is 2.1, and then that C is 6. So we get x is equal to, space is running out, so negative B, negative 2.1, plus or minus the square root of the 2.1 to be squared minus 4 times A, that's negative 0.4 times C, so times 6. and that's going to be all over 2 times a. That's 2 times negative 0.4. Okay. And you're going to work that out on your calculator. You're going to get two values. You're going to get x of 1 is negative 0.8. Can't use that because we're talking about something real, right? Talking about a distance that's real. Negative values does not exist in the real world, if that makes sense. The other value you get is 7.3. So the one you want is 7.3, right? Now, let's see if we can get this graph right. So we know that we have a maximum height. The maximum height is 8.8. See, this guy is above 15 for A. That's wrong. This guy is above 20 for the maximum height. That's wrong. This is stupid right here, right? Don't you mark that on your paper. Anyway, so just by default, this is the answer. Well, I mean, that makes sense. The height is about 8.8. And then, look, it's traveling over this guy right here. That's about that 7.3, right? So that's like where the height is. Boy, can you see that? And then over here is that total distance horizontally. That 7.6, 7.3 is what we got. I don't like that. Okay. All right. Let's look at this problem here. You have 450 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence here the side along the river, obviously, find the length and width of the plot that will maximize the area, and what is the largest area that can be enclosed. So since you're maximizing the area, we need the formula for the area. This is a rectangle. So the formula for the rectangle, the area, is the length times the width. So this is the width, and that's the length. So we have 450 minus 2x times x. Okay. Well, that gives us, we just worked that out. This is negative 2x squared plus 450 times x. It's a parabola. So when they talk about maximizing, and the reason why they can say maximize is because here a is equal to negative 2. So if that's the case, the graph for the equation would do something like that. So we get some maximum value. So to get that maximum value for this parabola, obviously we just want to find the vertex. So we're going to use x equal to negative b over 2a to find the value for x that they're wanting. X is that width, right? So let's label what we have. Notice that the a is negative 2 and the b is 450. So this is negative 450 all over 2 times here the a, and the a is negative 2. So that gives us 112.5. Okay. So here the width is at 112.5. So then the length is that 450 minus 2 times x. 450 minus 2 times that 112.5, and that gives us 225. What's the largest area? Well, we just multiply the length times the width, and we get it. So the area is equal. The largest would be based on here, that vertex. So we have the length, 225, times the width, 112.5, and that gives us 25,312.5. That's going to be feet squared, right? And so they want us to just get the an integer. So you'll put in there 25313, right? Just round that one up. And folks, that'll do it.